Hi everyone, welcome to the PGD-AI classifications, which is advanced class towards the additional classification models and all that, which will cover uh, various decision trees and other charts, etc. So our expert Jamie Tosawa has been doing an excellent job, and we look forward to hearing from him. The session 5.2 on classification and its use in various decision tree and charts, etc. So I will hand over now to Jamie Musawa. Jamie, go ahead. Take care. Thank you.
So thanks a lot for the introduction, sir. And so welcome everyone for Machine Learning with Python, Classification Problems, Session 5.2. In Session 5.1, we uh, covered the logistic regression, binary logistic regression to be precise. So in this one, we'll be moving forward with two other topics, which will be gain and lift chart and decision trees. So let's get started. So there are many now there are many cases that where AI is implemented. AI is talked about everywhere, even with by the people who are from the non-technical field, because it's making the life easy for them to work with. So some of the common use cases for AI that we can see from the organization or the company's perspective are these: the customer experience, supply chain, human resources, fraud detection, knowledge creation, research and development, predictive analytics, real-time operation management, customer services, chatbots and all. Then risk management and analytics, customer insight. How do customers are how are customers reacting to the services of the company? Then pricing and promotion. So let's talk about few of them. So the customer relationship management, the predicting customer churn, where the customer wants to continue their the interaction with the company's services or not. Then identifying potential leads, personalizing marketing efforts, then in for marketing and sales, segmenting customers for targeted marketing, predicting customer lifetime value, optimizing pricing strategies. For finance, fraud detection, uh, credit score and risk assessment, arithmetic trading. Operations and supply chains contain demand forecasting, inventory management, predictive maintenance. And for human resources, resume screening, employee retention analysis, or employee attrition rate, using employee attrition rate and stuff. Then or trying to know it. Then workforce planning. So as businesses or companies or organizations, they are implementing AI/ML in their organizations for various work, and which makes their working easy to and making it efficient as well. So how will they evaluate whether the implementation of the AI or ML is being effective or not? So what are the ways the implementation is effective for them? So for classification models, if the implementation is happening in a class in terms of classification models, the metrics used for evaluating these models are accuracy, which measures the proportion of correct predictions, precision and recall, which balances balance the model's ability to identify true positives while minimizing the false positives and false negatives. Then F1 score, which is a combination of precision and recall into a single metric. Then for regression models, for continuous values, the mean absolute error and mean squared error, as well as the root mean squared errors, are used, where mean absolute error measures average prediction rate, whereas MSE and root mean squared error highlight larger errors. Then R squared, which indicates the proportion of variance explained by the model. Then there are certain ways which we call as evaluating the models in a live manner. The above two are the offline metrics. The online metrics, the or the way companies can see or release their software or their product can be done in A/B testing manner or canary release. A/B testing is nothing but compares the AI model's performance to a control group, and canary release gradually roll out a new software version to a small subset of users to ensure stability before a full deployment is done. So, gain and lift chart, which are used for assessing the performance of the classification models. So gain chart is nothing but showing the cumulative proportion of the true positive cases as more of the population is included, helping businesses understand how effectively the model captures the positive outcomes. Then left chart compares the model's performance to random selection, indicating how much better the model is at identifying true positives. Geek for Geeks, which is a famous tutorial website, what they say about the gain and lift chart. So the gain and lift chart are two measures that are used for measuring the benefits of using the model and are used in business contexts such as target marketing. It's not just restricted to marketing analysis. It can also be used in other domains such as risk modeling, supply chain analytics, etc. In other words, gain and lift charts are two approaches used while solving classification problems with imbalanced data sets. So, imbalanced data sets, if a person is new or hearing it for the first time, imbalanced data set is nothing but having one kind of output in a more proportion in the whole data set than the other. For example, in target marketing or marketing campaigns, the customer responses to campaigns are usually very low. In many cases, the customers who respond to marketing campaigns are less than 1%. The organization will raise the cost. Basically, the organization want to reduce the cost of the marketing and also have more uh, uh, response level from the customers for their marketing. So in that sense, the gain chart and the lift chart are used. So let's see further how we implement it. So the gain and lift chart are obtained using the following steps. First, we predict the positive outcome in the logistic regression model and arrange the observations in the decreasing order so that we get the the outcomes with the highest probabilities first. Then dividing the data set into deciles. Deciles is nothing but dividing the data set into 10 parts. So calculate the number of positives in each decile and cumulative number of positive up to a decile. So a few points about decile. Decile division, the dataset is divided into 10 deciles based on the predicted probabilities of positive outcomes generated by the logistic regression model. Each decile is denoted by D1 through D10. Each decile represents 10% of the dataset, with the first decile containing the top 10% of the observations with the highest predicted probabilities, and so on. And that is the reason why we said that we will be arranging the observations in the decreasing order. The purpose of the deciles, they are used to analyze the distribution of positive outcomes across different segments of the population, allowing for the assessment of model performance and the comparison of observed outcomes to expected outcomes. The population income can be a good example for deciles, where the first one will contain the top 10% of with the highest income in the population. Then moving forward, the gain being represented mathematically. So gain is the ratio between cumulative number of positive observations up to a decile to total number of positive observations in the data. Gain chart is a chart drawn between gain on the vertical axis and decile on the horizontal axis. Then left, so left is the ratio of the number of positive observations up to decile I using the LR model to the expected number of positive up to the decile I based on the random model. So the left chart is the chart between the left on the vertical and the corresponding decile on the horizontal axis. And you can also see there how they can be represented mathematically, the gain and the left. So we are going to understand the gain and the left chart with the example of a direct marketing strategy of a banking uh, institution, where we are trying to predict a, a service of a term deposit from the bank and whether the client will subscribe to that term deposit or not after the client has heard about the campaign, heard about the term deposit from the campaign. So you can see the variables, the variable types, and the description about the data set. We have age, then job. The job type contains admin, blue collar, entrepreneur, a student, technician, employed, unknown, etc. Then marital status, then education, default. Customer has credit in default, yes or no. It's a categorical variable type. Then balance, housing loan, personal loan, previous campaign, the number of contacts performed before this campaign and for this client. Then subscribed, whether the client has subscribed to the term deposit or not. So we'll see how these variables are used and which ones will be important for us in the uh, uh, in the model and for the gain and the lift chart. So starting to work with the data set, and this is how we'll import it through pandas and read the CSV file. And when we display the top 10 or first 10 results, these are the entries that it shows. So this is the screenshot of it. You can see the on index 1, and the age is 33, job is services, marital status is married, education is secondary, then balance, housing loan, personal loan, current campaign, previous campaign. Previous campaign is 4 for this, and currently subscribed, and they are not subscribed. Then printing the information about the data set that we are using. So this is the bank DF that we created. Now printing the getting the info regarding the data set. You can see there are 4521 entries from 0 to 4520. We have 11 columns to work with, and the object data types are nothing but the categorical data types. So, and the memory usage for the data set. Then we are trying to predict the X and predict the Y based on X. So we have to create the features. So we'll create the X features, and we'll remove the subscribed column from the bank DF columns. And so when we print the X features, this is the output that we get from age to previous campaign. And you can see there is no column named subscribed. Then creating the dummy variables for categorical values. So we'll call it encoded bank DF. And then after creating the dummy variables for the bank DF, we will assign it to X, which will be encoded bank DF. So when we train the model using the logit function and fit it, and when we get the summary of the logit model that we created, the logit model that we created, this is the summary, and this is how the summary is printed. You can see all the columns being printed, the coefficient, the standard error, Z value, probability values compared to Z, and the range of the probability value. So as you can see that here we had a lot of columns, and we don't know which ones are the significant ones. So now we will be creating the significant variables with the and we'll be defining a function called get significant variables, get the data frame, and get the variables as well as their probability values. And the probability values being smaller than 0.05 will be our significant variables. So after running the function on the logit model, we'll assign the result with the significant variables. So when we print the significant variables, the list that we get is the current constant, current campaign, previous campaign, job, retired, then married, educational tertiary, housing loan yes, and personal loan yes. Now creating the X features with the significant variables. Remember, we created the X features first with all the variables. Now we'll be creating with all the variables except subscribed. Now we'll be creating it with the help of significant variables. So all the significant variables are assigned to it, X features, and then again uh, training the logistic model and fitting it. This is the summary of the logit model 2. First one was the summary of the logit model. This is the second model that we trained, and we are printing the summary of it, which was trained only on the significant variables. So this is the summary of it. Now we are trying to predict the probabilities. So we'll be creating a Y prediction DF, which we'll be calling Y pred DF, and we'll be passing the actual and the predicted probabilities of the logic model that we just created. Now sorting them in the descending order to get the highest values first, and creating the predictions and sorting them, converting the observations into deciles. So first we will see how many observations are there per decile. So when we print the observations, we get 452. So there are 452 observations per decile. Now we'll be creating a function called get deciles, and that get deciles will be marking all the observations with their with the with its respective decile number. So when we create this using the get decile function and pass on our sorted predict df, then the results of the first 10 observations you can see in the on the screenshot. Now we calculate the gain. So gain, as also previously mentioned, is the cumulative number of positive observations up to decile I divided by the total number of positive observations in the data. So, first creating the gain lift df, and then calculating the gain percentage on it. So when we print the gain lift df, and this is the uh, for the 0 to 9 are nothing but the deciles. So this is what the gain decile and the gain percentage looks like. And you can see that for the first 5 or for the first 5 index, which for the first 5 deciles, we have got the gain percentage of 70. So after that, you can see that the gain does not uh, gets in the same rate. Now plotting the gain percentage against the deciles. So we have used the matplotlib and cpon, and then plotting the figure for the gain and the lift. Sorry, the decile gain and the decile on y and x respectively. Next is calculating the lift. Of course, lift is a cumulative number of positive observations up to a particular decile I using the logistic regression model divided by the positive observation, cumulative number of the positive observations up to a decile I based on the random model. So gain lift df, the lift is used, and it's it has been translated into it's from mathematical to the coding form. And when we print its gain lift df, this is the an additional column is added to the previous gain lift df that we had. And as you can see that an additional column lift is used in order to save those results. The final gain lift df would look something like this. Now plotting the graph on on the left against the decile. So this is what the graph would look like. So the model can capture almost 2.4 times the number of subscribers compared to the random model. After after discussing the gain and lift charts, we'll be moving and starting with the classification trees or the decision tree learning. So what are decision trees? If we talk about trees, so you can see the image on the bottom. This is what a tree looks like. It has its level. The starting or the top node is called the root node. Its subsequent nodes are called child nodes, and those child nodes can have their own child nodes, which makes them their parent to the child that they have. The line connecting the two nodes are called edges, and the last nodes which don't have further uh, which don't go grow further, they are called leaf nodes. So this is a, a basic example of a tree. Now, how they are used in computers as well as in machine learning. So decision trees are models working resembles to trees where we have nodes as choices and branches with possible outcomes. Each data is classified until it is predicted with high accuracy and efficiency. A decision tree is a decision support hierarchical model that uses a tree-like model of decisions and their possible consequences, including chance, event outcomes, resource costs, and utility. It is one way to display an algorithm that only contains conditional control statements. Now, a part of a decision tree is also called a random forest. A random forest is nothing but a combination of multiple trees or multiple decision trees, and we collectively calling it as forest with trees and combining their results to create the prediction. The prediction is combined with the help of averaging it and so on. So this is the example of a tree being used as a mathematical form or for other events. And the third one contains the example of a random forest. So first you can see a mathematical expression being represented as a tree. The other one contains some of the events and what are the outcomes to it. The third one is the random forest. There are 4 total trees. Their their predictions and their predictions being used as a collective prediction is used. So classification trees starts at the root, having the whole data. When so this will be this explanation will be regarding the data sets and how the classification tree is used on the data sets. So starting at the root node, having the whole data, further creating subsets and splitting the data into multiple branches and creating the child nodes based on different smart conditions to divide the data. This splitted data creates homogeneous groups of children nodes. So trees are one of the most uh, powerful predictive analytics techniques used for generating business rules. Business rules is nothing but how an organization wants to conduct their particular operations. So classification and regression tree. Uh, also called as CART. It as a classification regression, both are used together. It becomes a common term or a umbrella term for them. So whenever the outcome of the tree is a discrete value, we'll call it a classification tree. And it's when the outcome of the variable is a continuous value, we'll call it a regression tree. So so they measure the disorder or impurity in a data set, helping the algorithm decide best feature to split on at each step. So there are particular splitting techniques that are used in for decision trees. So classification trees uses various impurity measures such as the Gini impurity index and the entropy to split the nodes. Entropy basically meaning randomness. So a regression tree, on the other hand, splits the node that minimizes the sum of squared errors, SSE. So that's why they say that they measure the disorder or impurity in the data set while helping the algorithm to further split the data. So a decision tree is a greedy algorithm we use for supervised machine learning tasks such as classification and regression. So now we'll discuss the steps to generate the classification and regression trees, starting with the complete training data in the root node, then splitting that decision trees. So as discussed, there are two techniques. One is Gini impurity index, and another one is entropy. Gini index is related to misclassification probability of a random sample. Entropy, in the context of decision trees, entropy is a measure of disorder or the impurity in a node. Then splitting the data, the quality of splitting data is very important during the training phase. When splitting, we choose to partition the data by the attribute that results in the smallest impurity of the new nodes. The fourth step, deciding on the measure of impurity, whether Gini impurity or whether to go with the Gini impurity or the entropy. So we search for the predictive variable that minimizes the impurity when the parent node is split into child nodes. This happens when the original data is divided into two subsets using a predictive variable that it results in the maximum reduction in the impurity in the case of the discrete dependent variable or maximum reduction in SSE in the case of a continuous dependent variable. Now we repeat the step 2, which is splitting the data with the selected splitting technique until all the dependent variables are exhausted and or the stopping criteria are met. So few stopping criteria used are a number of levels of a tree from the root node, minimum number of observations in parent child node, example 10% of the training data, and minimum reduction in impurity index. Now generating the business rules for the leaf or the terminal nodes of the tree. So we'll be using the scikit-learn to make or generate our decision trees. So you can see the general syntax of the scikit-learn tree decision tree classifier. There are various parameters that it accepts from criterion to minimum leaf, sample leaves, minimum weight fraction leaf, maximum features, random state, max leaf nodes to monotonic CST. Now, there are many parameters, but what we will be working with are a criterion. There are 4 of them, starting with criterion, which is a string, and by default, its value is Gini. which is Gini impurity. And if we want to go with entropy, we can enter the entropy. Then there is max depth, which takes the int type, the maximum depth of the tree, then minimum sample spread, which takes int or float. The int meaning that there will be number of samples, and if float, then the percentage of total number of samples is used. So by default, it's int, and and the value is 2. Then in samples leaf, it again takes int or float values, the minimum number of samples required to be at the leaf node. So for discussing the Gini impurity and the entropy, we'll be using this data set that we have used in the session 5.1 as well. So this is the same banking data set where we were trying to predict the bad credit from the given variables, and got a significant variables over here too. So what I would like to highlight over here is the screenshot on the top left, which takes the checking account, which is a categorical variable type, and its categories. So from A11 to A14, A14 having no checking account. Then on the the duration, and now after that, coming on the right, there is the third row called interest rate, and the last row, which is status of good credit and bad credit. The good credit is 0 and bad credit is 1. So these are some of the rows that we'll be working with, or will be coming in handy in order to how they are represented by the bank's data set. So first, we'll be creating the X and Y features, the credit DF, whether it's a bad or the good, and the encoded credit DF, which basically contains the the variables with the encoded dummy variables. Then we train the model. First we spread the model. Sorry. First we spread the model. First we spread the data set, and we'll be splitting the data set in a 70-30 ratio. Then using the Gini criterion on the decision tree classifier, and then CLF dot fit on the X and Y's training data split. We'll get these. We'll get this output. Then measuring the accuracy of it. So we'll be measuring the accuracy using the ROC AOC score. So tree predict, and then giving the X test data set on it, and then passing the matrix ROC AOC score on Y test and the tree predict. For that, we got the output of 0.58. Now, as we are trying, now we'll be trying to graphically present the tree. So for that, we will be using the GraphViz software, and also we'll installing a dependency called py.plus. So using those two, we'll be moving forward. So now for displaying the decision tree. So first, we will be exporting the graph width, then importing the py.plus, for displaying the tree and importing the image. Import image. Now we export the tree into the ODT file. So we export the GraphViz file, then use the class names that are good credit and bad credit that we are trying to predict, or uh, and then read the create image the image file, and then in the end rendering the PNG file of the image. When we execute that code, this is how the decision tree will. This is how the decision tree we get. You can see on the root node there are number. This is done using the Gini splitting technique, and there are a number of samples that are present are 700. Out of them, 491 are good credit, good samples or the positive samples, and 209 are the bad credits. And you can see further conditions on based on which the data has been spread. So some of the interpretations for the decision tree that we just saw. The top nodes, as I said, that 700 observations, 491 are good, 209 are bad. And the corresponding Gini index on that was 0.419. Then the checking account A14 was nothing but having no checking account. Means having no checking account is the most important feature for splitting good and the bad credits in the dataset when compared to other features, and hence chosen at the top splitting criteria. The first rule for splitting comes A14 smaller than 0.5 means if the customer has checking account or not. This rule has split the dataset into two subsets represented by the second level nodes. On the left node, there are 425 samples, and on the right, there are 275 samples. Of 275 samples having the checking account. Then we'll be going to the sixth point. The fifth point basically shades the darker shades for good and the lighter shades for bad. The sixth point is one of the rules can be interpreted as if the customer does not have checking account A14 and the credit duration is less than 33 and does not have saving account as A65, then there is a high probability of being a bad credit. There are 70 records in the dataset that satisfy these conditions, and 48 of them have bad credit. Another thing is if the customer has a checking account A14 and interest plans A143, and the age is more than 23.5 years, then there is a high probability of being a good credit. Now, understanding the Gini impurity mathematically. So it's nothing but a summation from the observation, starting from observation I equals to 1 to C for the probability of K into 1 minus probability of K. So Gini measurement of the probability of a random sample being classified correctly if we randomly pick a label according to the distribution in the branch. Gini impurity can be computed by summing the probability Pi of an item with label I being chosen times the probability of 1 minus Pi of a mistake in categorizing that item over all the classes. So if impurity reaches 0, uh, all the cases belong to a specific category. So Gini impurity for the top node in the decision tree will be 0.149, but we got it with the help of the implementation of the formula that we just saw. Now, building the decision tree using the entropy criteria. Remember, we use the Gini criteria. Now we'll be using the decision tree to be made using the entropy criteria. So, assuming there are j classes labeled 1, 2, 3 till j, the entropy at node k is given by starting with j equals to summation of all the classes starting with sorry. Entropy equals to minus all the summations of j equals starting to 1 to all the classes for a particular class j, probability of particular class j or k, the log and the logarithmic value of j for k. The value of entropy lies between 0 and 1, and the higher entropy indicating a higher impurity at the node. So, and this is how the tree using the entropy split would look like. The entropy value on the root node, you can see that it's 0.88 in the samples, and the values are 491 and 209. And then further down, they are split depending on the given conditions. Now, some of the interpretations for the decision tree that we created using the entropy criterion. The nodes represented by dark shades depict majority good credits, while the nodes represented by lights are majority bad credits. Rules generated at the top two level nodes are same as rules generated by the decision tree build using the Gini index. This one, you can see the duration and interest plans and the checking account for the level 2 and level 1. This is the same criteria that was used to split, or the condition used to split the data in the Gini index as well. So one of the rules can be interpreted as if the customer has a checking account A14, interest plan code A143, and the credit history code, which is A34, then there is a high probability of being good credit. So there are 96 customers who satisfy these criteria, and 94 of them have good credit. You can see the leaf node, which lies at the top right. The bottom right. The entropy of 0.146. The samples are 96, and the values of them 94 being good, 2 being bad. Now, calculating the entropy mathematically for the given formula of the entropy, we get the output of 0.88. We are importing math because we want to use the log function. Now measuring the test accuracy using the AUC, or area under the curve, for the tree using the entropy criteria, and we get the value of 0.5763. So finding the optimal criteria and the max depth. So this is nothing but the optimization of the tree, and which are the variables or the features that affect the most for the outcome, and identifying them. and which is the maximum depth that is needed for the tree. So for doing this, we have the scikit-learn's in the scikit-learn's model selection. There is something called grid search CV, which provides the hyperparameters as well as their most optimal values. So grid search CV needs to be provided with the accuracy measure to be used for searching for the optimal value. For classification models, ROC, AOC values are used, and it uses k-fold cross validation to measure the accuracy. So we'll discuss a bit about k-fold cross validation. So this snippet is taken from the machinelearningmastery.com. So it's from there. So cross validation is a resampling procedure used to evaluate machine learning models on a limited data sample. If you have a machine learning model and some data, and if you want to tell if your model will fit it or not, so you can split the data into training and test, train your model in the training set, and evaluate the result on test. But you evaluated the model only once, and you're not sure of the result. So the procedure has a single parameter called K that refers to the number of groups that a given data sample is to be split into. As such, the procedure is often called k-fold cross validation. When a specific value of k is chosen, it may be used in place of k in the reference of the model, such as k equals to 10, becoming 10-fold cross validation. So the cross validation is primarily used in applied machine learning to estimate the skill of the machine learning model on unseen data. So I hope this use of the k-fold cross validation over here makes sense more now for the grid search CV. So the grid search CV can be used in the machine learning model and can search through multiple hyperparameters of the model. So the arguments that it takes are estimator, parent grid, scoring, and CV. Estimator is a scikit-learn model which implements the estimator interface, a dictionary. Param grid is a dictionary with parameter names as keys and list of parameter settings to try as values. Then scoring is a string, is the accuracy measure, that is ROC, AOC, and CV is an integer which gives the number of folds in the k fold. For this explanation, we took k equals to 10, and so C was equals to 10. So configuring the grid search to search for the optimal parameters, splitting the criteria given Gini or entropy, then maximum depth of the decision tree ranging from 2 to 10. The searching of the optimal parameter will be validated using k equals to 10. So 10-fold cross validation, and the most optimal parameter will be chosen based on the ROC AOC score. So this is the whole code for generating or knowing the optimal parameters. So we use the model selection and imported grid search CV. We discussed about the parameters that it or the arguments that it takes, and gave the required values to it. So in the CLF equals to grid search CV, you can see the CLF tree tune parameters, CV equals to 10. Then scoring is used. For scoring, we have used a ROC AOC curve. And when we use the CLF.fit on the X train and the Y train data split, this is the output that we get. And to summarize this, the criterion that we need is a Gini, and the max depth of the tree that we need is 4. These are the best criteria for it. So benefits of using a decision tree. So rules generated are simple and interpretable. you can see how the machine or how the model is making the interpretations and why is it choosing what it chooses to be. The the trees can be visualized, as we have seen two of the visualization of it using the Gini and the entropy. Then work well with both the numerical and the categorical data, and do not require data to be normalized or creation of dummy variables. And rules can help create business strategies. So just to summarize the whole session, we we started with the first gain and lift chart. So we used the bank CV bank.csv dataset and created DF. Then printed the first 10 entries in it the information regarding the dataset. There were 4521 entries. The age are the only int data type. Age, balance, current, and previous campaign are the only int data type. Others are categorical data types. Then we created the features for training the model, made the dummy variables using the pd.get dummies, and then use the encoded df as the as the x. Then train the model, and this is the summary of the trained model that we got. And this is the same screenshot that was used in the slides as well. Then these were many variables, and then we tried to recognize the most significant ones with the help of the get significant variables. We passed the get significant variables on the function of the and passed it for our model that we created, which was logic model, and the significant variables were this. Then making the x features of the only significant variables, and making a new model, logic model or the logistic model 2, training it, and this is the summary of the logistic model or the logic model 2. Now predicting the probabilities for it, the predicted probability of y on the x and the actual probability in the y. Now using a sorted DF for the predicted and actual, as you remember, we are trying to make a decile, and we are trying to have it in a descending order, or having the observations with the highest probability appear first. So that's why we are giving the ascending equals to false. Then calculating how many observations are there in per decile. 452 is the answer to it. Then creating the deciles, creating the deciles, getting the number after each number of decile has been created, the number or after each observation has been done, the or the corresponding decile decile index has been marked with it, and after creation of it on the sorted predict DF, this is the decile prediction for the first 10 that we get, for the 10 that we get. Then calculating the gain on it for the decile and the gain, and then the gain percentage. And when we create the whole, when we print the whole gain lift DF, right now it's only gain, with respect to the deciles. So this is what uh, the numbers look like. And remember, I pointed out about for the first five, we have acquired almost 70 of the positive results. Then plotting the chart of gain against a decile, this is what the output would look like. Then calculating the left, and this is how we calculated the left. And when we print it, this is the output to it. And again, we'll be plotting the graph of the left against the deciles, and this is the graph to it. So now to just a second. So now to summarize the decision trees, we started with encoded credit DF and the credit DF. Encoded credit DF is the dummy variables that we created in the session 5.1. So same encoded DF will be used over here, splitting the data in a 70-30 manner. Then using the decision tree classifier and splitting the tree using the Gini index. This is what the fit tree looks like. Uh, this is how we fit the tree by passing the x and y variables to the CLF tree. And this is the output that uh, was shown in those slides. Now testing the accuracy of the tree that was created using the ROC AOC curve. This is the output that we got. Now displaying the tree that we have created using the graph is, remember if I pointed out about the graph is being installed first, and then using the using pi.plus also to be installed using pep. So after running this code, and this is the tree that is created using the Gini index. And just to say it prior, the splitting conditions of the Gini and the entropy for the first two levels, which is the root and this level, was same. So which was a checking account A14, duration and interest plans. Now calculating the Gini index mathematically, this is what we get. And this was the same score, 4.419, and this is 0.4189, just approximated. Then the making the decision tree using the entropy. Just a second. Yeah, so making the decision tree using the entropy, only passing the criterion entropy over here. And after running this code, this is the tree that we get. And remember, I told you about the level 1 and the level 2 being the same conditions to split the data. The entropy is 0.88. That will be calculating mathematically over here too. And we get the 0.8 value as well. Now measuring the accuracy of it using the ROC AOC curve, using the metric.ROC AOC score. This is the score that we get, which is 0.57. Then remember we discussed a topic on optimal criteria and the max depth. So using the grid search CV, we took these parameters. The CV equals to 10 is k fold, k is value 10, and using scoring is done using the ROC AOC, and the criteria to be compared were Gini and the entropy. So the best score was 0.68, and the parameters that we wanted from that from those decision trees, or the optimal values that we wanted from both the decision trees, and the depth was criterion for Gini, and max depth for the trees were 4. So these are the references that was used specifically in the uh, session 5.2, and these were the references for session 5.1. So yeah, thanks a lot for attending this session or listening to it. This was the session on classification problems. Thank you.
Janice, excellent.
Yeah.
Do you plan to cover the forests, trees and the forests sometimes, or was it not in the plan?
No, because we were talking about the trees, I just mentioned it.
Okay,
It was not.
it's not part of the section.
No,
Okay,
no.
fine. It will come under advanced whatever.
Yeah.
Yeah, advanced classification. So next you are going to take up advanced planning or
Uh,
any?
it
Yeah.
mostly
Okay.
it will be advanced Python machine
Okay.
learning,
Okay.
but
Excellent. Mm-hmm.
depending the on the topics related to the flow that we are going,
Mm-hmm.
it can be changed.
Okay. I leave it to you. So I think excellent job going through all the Gini and various entropy selection criterias and probabilities and decision trees and excellent. I think it conveyed the best approach. The only thing is the Jupyter notebook, which is there, if you can load it up to in the drive somewhere,
Sure.
both of them, the previous one, and then we can share with those who really are going to follow on the courses. So,
Yeah.
with that, I think we will close the recording today and I'll post it as soon as it's ready. And hope next session will be on again Friday.
Yeah.
We'll be skipping Wednesday and again we'll be having Friday and Monday.
Yeah.
Okay.
Yeah.
So, well done. Good job. You have finished 5-2. Now it is 6-1, 6-2, or 6-7. I
Yeah.
don't know. I'll leave it to you. But
Yeah.
that's excellent progress. We have maintained the consistency, which is important. And let's share everything with the study circle and find out what feedback we get. Okay.
Yeah.
Thanks a
Sure.
lot. Have a
Thanks.
great day. And I'll close the session. Thank you.